In the 1990s, speaker brands raced to add extra terminals, claiming bi-wiring was the secret to high-fidelity perfection, while insiders like Roy Gregory warned something was off. For decades, owners have debated whether this is a genuine performance breakthrough or just a leftover marketing myth. The truth inside those speaker terminals, what actually happens when you buy wire or buy amp, holds surprising consequences for your system and your wallet. What are you really hearing, and what are you just being sold? By the early 1990s, the hi-fi world was buzzing with a new promise. More terminals meant better sound. Speaker brands like Bowers Wilkins, KEF, and Wharfedale rolled out models with 4 binding posts, each set labeled for high and low frequencies. The message was clear. If you cared about audio quality, you needed to ditch the old single wire setup and grab a pair of thick bi-wire cables. Magazine ads and glossy brochures painted a vivid picture of sonic transformation. Phrases like veil-lifting clarity and untapped potential filled the pages, all pointing to those extra terminals as the gateway to true high fidelity. Cable companies were not far behind, bundling bi-wire sets at a premium and promising that a few extra meters of copper could unlock details you had never heard before. Profit margins on accessories soared. A set of bi-wire cables often cost as much as an entry-level amplifier. Retailers and sales reps leaned into the hype, offering package deals and expert advice that bi-wiring was the next logical step for anyone serious about their system. Testimonials poured in, some real and some less so, claiming jaw-dropping improvements from swapping out a pair of jumpers for 2 runs of cable. The culture of the time thrived on these stories, fueling a gold rush for upgrades that seemed both technical and magical. Roy Gregory, then a rising voice in the British audio press, watched the trend from the inside. He questioned the claims, pointing out that few, if any, of these upgrades came with hard measurements or blind listening tests. Instead, most of the evidence was anecdotal, stories traded at hi-fi shows, repeated in forums, and amplified by the industry's need to sell something new. Behind the scenes, the real driver was simple. Accessories meant profit. A 4-terminal speaker cost little more to produce than a 2-terminal one, but it opened the door to a whole range of cable sales and system upgrades. For many brands and retailers, bi-wiring was less about engineering and more about economics. The promise of a free upgrade with the right wire kept customers coming back, even as independent tests struggled to show any real change. The stage was set for a showdown between marketing and measurement, a debate that still divides audiophiles today. Peeling back the rear panel of a typical 4-terminal speaker reveals a story that is far less mysterious than the marketing would have you believe. At the heart of the design are 2 sets of binding posts, one labeled HF for high frequencies, the other LF for low frequencies. These posts are not connected directly to the speaker drivers. Instead, they feed into a passive crossover network, a circuit made up of inductors and capacitors carefully arranged on a circuit board. This network decides which frequencies reach the tweeter and which head to the woofer, splitting the signal at a set crossover point, often around 2000 hertz or 3000 hertz. Though the exact value depends on the model, the crossover point is what determines which driver handles which part of the music. The metal jumpers that come pre-installed on most 4-terminal speakers act as bridges between the HF and LF posts. With the jumpers in place, a single set of speaker wires from your amplifier sends a full range signal into both sections of the crossover simultaneously. The crossover itself does the heavy lifting, filtering out lows from the tweeter and highs from the woofer, ensuring that each driver only receives what it is designed to handle. When you remove the jumpers, you are separating the input paths. Now, the HF and LF sections can be fed independently, either by 2 sets of cables from the same amplifier channel in a bi-wiring setup, or by entirely separate amplifier channels in a bi-amping configuration. But here's the key. The internal crossover topology does not change. The signal still gets split at the same point, the same way, by the same components. No matter how elaborate the wiring on the outside, the crossover remains in charge of frequency allocation. This means that with jumpers in place, the speaker's internal wiring makes all the decisions. The only variable left to tweak is how the signal arrives at those posts. Bi-wiring and bi-amping are just different ways of delivering the same electrical energy to the same circuit, unless you move to an active crossover outside the speaker. For most systems, the anatomy inside the box is what truly shapes the sound, not the number or arrangement of cables running from your amplifier. Amir Majidamir, founder of Audio Science Review, set out to test the claims behind bi-wiring and bi-amping using a suite of measurement tools. And with a calibrated UMI K1 microphone, REW software, and a pair of Bowers Wilkins floor standers, he ran frequency sweeps, distortion tests, and headroom measurements. The numbers told a clear story. Switching from single wire to bi-wire, the frequency response shifted by less than 0.1 decibel, well below the threshold of human hearing. Total harmonic distortion remained unchanged, and the amplifier saw nearly identical impedance curves. Any difference in sound, Amir noted, was lost in the noise floor. Blind listening tests reinforced the lab data. Panels led by figures like Till Hertzens and John Darko used ABX comparators to level match and randomize single wire and bi-wire configurations. Listeners were tasked with picking which was which, using music from classical crescendos to bass-heavy pop. The results hovered at chance. No one could reliably tell the difference. Even when testers repeated the trials at higher volumes or with more revealing speakers, outcomes stayed flat. Subjective reports of lifted veils and expanded soundstage faded under controlled conditions. Bi-amping, on the other hand, produced measurable changes. Passive bi-amping, using 2 amplifier channels per speaker, one for highs and one for lows, delivered real benefits on demanding floor standards. Headroom increased by up to 7 decibels in the low frequency band, allowing louder bass passages before distortion set in. Total harmonic distortion in the bass dropped from around 0.5% to 0.3% below 80 hertz. Impulse response graphs showed tighter bass transients, especially on tracks with deep kick drums or orchestral swells. These gains did not appear on bookshelf speakers or with powerful single amplifiers, but for large speakers in big rooms, the difference was clear. The final verdict from the data: bi-wiring offers cosmetic changes at best, with frequency and distortion shifts too small to matter. Passive bi-amping, when matched to the right system, unlocks genuine improvements in power handling and low frequency control. The numbers, not the marketing, draw the line between myth and upgrade. Rear panels on Marantz, Yamaha, and Wharfedale amplifiers often feature dedicated A and B speaker outputs and pre-out jacks, making passive bi-amping accessible to anyone with the right gear. The process begins with a careful inspection. Both your amplifier and your speakers need to support bi-amping. Look for 4 binding posts on the speakers and check for dual outputs or assignable channels on the amplifier. Product specialists from Marantz and Yamaha recommend removing the metal jumpers from the speaker terminals before wiring. Leaving those jumpers in place while connecting multiple amp channels risks shorting outputs and damaging the amplifier. Start by connecting 1 amp channel to the low frequency post and another channel to the high frequency post, matching polarity for each run. Studio engineers stress using cables of equal length and gauge to maintain balance, resistance, and prevent subtle timing mismatches. For integrated amps with assignable channels, such as Yamaha's AS1200 or Marantz's PM7000N, activate the BI amp mode in the setup menu to reroute unused surround channels to the high frequency posts. Wharfedale's RA series provides independent speaker outputs, but always double check the manual for correct configuration. Gain matching is critical. Unequal gain between the high frequency and low frequency amplifiers can create a tonal imbalance, making the speaker sound either too bright or too boomy. Use the amplifier's controls or a preamp to ensure both channels deliver the same output level. A simple test tone and an SPL meter at the listening position can help dial this in to within half a decibel. Impedance dips in the low frequency section, sometimes dropping to 2 or 3 ohms, can overload an underpowered amplifier, so monitor for signs of distortion at high volumes. Product specialists advise starting at moderate listening levels and increasing gradually, watching for clipping or amplifier protection circuits engaging. A return on investment depends on the system. Borrow a second amplifier or use spare channels if available. Buying new gear solely for bi-amping rarely pays off unless your speakers are large floor standers and your current amplifier struggles with bass-heavy music. Studio engineers point out that in professional environments, passive bi-amping is reserved for scenarios where extra headroom and tighter bass control are essential. For most home setups, the benefits become clear only when the system is pushed near its limits. Testing with demanding tracks and careful setup is the best way to hear any improvement for yourself. Today, audiophile myths persist. Even as research shows most upgrades offer little measurable change, as the market pushes new tweaks, real improvements remain rooted in evidence. not cable claims. The true pursuit of better sound demands skepticism, not just belief. What's your experience? Join the conversation below.